Good morning, students. Today, let us study the lesson 9 Atomic and Nuclear Physics and see the topic Electric Charge through Gases. It consists of long closed glass tube. Inside of which gases in pure form is filled usually. The glass tube of length nearly 50 centimeter and diameter 4 centimeter. Then the small opening in the tube is connected to a high vacuum pump and a low pressure cage. This tube is fitted with two metallic plates known as electrostats, electrodes which are connected to secondary of an induction coil. The electrodes connected to positive of secondary is known as anode. A symbol is anode. And the electrode to negative of secondary is cathode. The potential of secondary is mentioned about 50 kilowatt. Suppose the pressure of gas in discharge tube is reduced to around 110 millimeter of mercury pressure using vacuum pump. It is observed that no discharge takes place. When the pressure is kept near 100 millimeter of mercury pressure, is the discharge of electricity through the tube takes place. Consequently, irregular streaks of high appear and also creaking sound is produced. When the pressure is reduced to the order of 10 millimeter of mercury pressure of luminous column known as the positive column is formed anode to cathode. When the pressure reaches to around 0.01 millimeter of mercury pressure, positive column disappears. At this time, a dark space is formed between anode to cathode, which is often called Crookes dark space, and the walls of the tube appear with green color. At this stage, some invisible rays emanate from cathode called cathode rays, which are later found a beam of electrons. That's all. And then properties of cathode rays. Next, we see the properties of cathode rays. Cathode rays passes energy and momentum and travel in a straight line with a high speed of order 10 power 7 millimeters meter second power minus 1. It can be deflected by application of electric and magnetic fields. So the direction of deflection indicates that they contain negatively charged particles. When cathode rays are allowed to fall on a matter, so the metals are very high heat. then it will produce very high heat. The cathode rays affect the photographic plate and also produce fluorescence when they fall on certain crystals and minerals. When the cathode rays are allowed to fall on a matter, heat is produced. Then the cathode rays affect the photographic plate. So, third point, when the cathode rays fall on a material of high atomic weight, X-rays are produced. Cathode rays ionize the gas through which they passes. The speed of cathode rays is up to 1 by 10th of the speed of light. That's all.